Okay, lecture module 10, systems analysis and design. I will tell you at the start here, systems analysis and design is probably the most exciting endeavor you can get into in this discipline, at least for me. Just designing, developing, and implementing a system is incredibly rewarding. It may be one of the most boring things to read. So take that with that caveat. Um, so where are we? Systems analysis and design. If we look at where we are in the world today, the world has changed in the last 20 years. And again, me being much older, I've seen it, I've observed it. We've seen the rise, the emergence, the quick evolution of the internet and World Wide Web. And really, when we look at those, it's the standards, okay? It's that adherence to standards and then accessibility because of the standards. So everyone can participate. Um, and a lot of this, we look at, we always had client server computing since the 60s, but now it's extended to cloud computing. Again, accessibility because of standards, internet standards, and then also web accessible standards, W3C compliance. So again, everything we've learned up to this point is really coming into focus here. It's really being integrated in what we're learning here in this chapter. Now, systems analysis and design is a full-blown discipline. We here at Hudson Valley actually have a two-course sequence in it. We're in CISS 100, we just have a single chapter. They have entire curriculums, undergrad degrees that focus on systems analysis and design. They have masters, PhD. You can do, graduate work in just a very small subset, small, slice of what is systems analysis and design. So again, we're just going to kind of dip our toes in, but we need this conceptual background to really progress. Now, you've heard me state something. You know, we've always spoken about information technology. And up until, this point, maybe even a couple of years ago, the focus has always been on technology. When I say technology, the hardware and the software. That's really what we're looking at with, systems analysis and design, at least historically. But the focus has now shifted to the information. Our technology is fine. Our computers are quick enough, they will get faster, of course. Our communications channels, everything will get faster. Hopefully, we'll get more efficient. Hopefully, we'll get more secure over time. But really now, the focus is on information and who possesses that information. And what I'm speaking about here, of course, is AI, artificial intelligence, and the subset of AI that is machine learning. And when I say machine learning, what I'm really talking about is the deep learning algorithm. I'm not going to get into that in more specifics than that at this juncture. So it's really who controls the data because they can learn more, okay? What these programs do, and maybe I'll give a quick overview. Um, I was close to this when it was evolving. My background, my grad work is artificial intelligence. My brother is an attorney, but he also had significant computer science knowledge. And he was working for Deloitte and Touche and FTI Consulting. And it just happens, he was at the right place at the right time, and he was asked to develop a machine learning algorithm for legal purposes. And it was actually used as the basis of the Apple versus Samsung case, that multi-billion-dollar case. And what the machine learning allowed is you had all these court documents. They actually had over 1 million documents, memos, emails, things like this. And in the past, they would have hired, 100 new grads from law school, and they would have had them read all the memos, things like that. But in the beginning, when an attorney first reads these things, they don't really know what's important, and they don't have time to read it again. So over time, of course, they get better. But with a computer, of course, it can go through the documents over and over. What it actually does is tokenizes them. And then it looks at the relationships of how these tokens relate. So over time, its understanding of the details of the case get better and better. My brother estimated it would have taken those 100 attorneys well over 6 months to read all those documents. How much What does an attorney make? Times 100 times 6 months. What would have that been that cost? The computer, the machine, did it in 10 minutes. That's where we're going. So when people talk about AI and machine learning, that's what we're talking about. 100 attorneys, 6 months versus a machine in 10 minutes. Um, so that's important. So that's what's really going on with these deep learning algorithms. And I'll give you one more example. A team of computer scientists were fed all of this medical information, and they fed it into the deep learning algorithm to create new drugs. They identified more new drugs, so not a single physician or doctor among them identified more new drugs in a 1 month period than a major pharmaceutical firm and all of its resources in a year. This is one of the reasons that Google wanted to get into medical research. Who has the data? Google. Okay. Um, Facebook, all of these companies are leveraging the information. Now, again, there are other concerns: privacy, ethics. Okay, so again, we've seen this shift in information technology from the focus being on technology to the focus being on information. But again, we need systems analysis and design to develop these systems to accomplish both. Okay, so in order to remain competitive, especially with what's going on, and we've seen, of course, the rise of the internet and the web, and then, of course, this pandemic and lockdown has thrust everyone into this online world. And again, in the back of our minds, we have to think, okay, everything's taking place online. There's a lot of data and information there, going back into that machine learning. Um, so I won't say much more about that. I do, when we look at this from an architectural perspective, and I'll cover that in just a minute again, architecture versus infrastructure. The core of all information systems, again, the core of all websites today are or is the relational database management system. Okay. The database sits at the core of all management information systems and, of course, computer information systems. When you think about the college's registration process, you're registering for courses. Where is all that data saved? In the database. Now, I'll talk about enterprise architectures here in just a minute. One caveat I want everyone to consider and keep in mind is that business drives. Technology is going to continue to evolve, and we love technology. We love it. And we're compelled often to, hey, here's this new technology. How can I apply it? Okay, that's backwards. Okay, we never adopt or seek a purpose to implement a new technology. It must be driven by business needs, business drives. And when we talk about business, in this course, we focus a lot in communication, information systems. We're communicating, okay? Business goals must drive our decisions. But when we're talking about those decisions, that communication, the communication mechanism in business is accounting, okay? There's a cost to everything. So when we look at information systems analysis and design, we look at cost benefit analysis, CBAs, return on investment, ROI, total cost of ownership, TCO. Okay. Now, I'm not saying that the metrics, the communication is entirely quantitative, number based. There are qualitative aspects as well. Okay. Customer service. You look at Amazon, okay, and Amazon's free returns, things like that, and they really do make it easy. You can order things, and especially in during this lockdown, order things, try them on in your home, send them back if you don't like them at no additional cost. Now, of course, Amazon has built this into their business model, and they've done a lot of negotiations with these shipping companies, but still, it's kind of a qualitative customer service. And I can pose the question, when you are looking for a new product, how many of you kind of go to Amazon just even to do research? Because I want to read about it. I want to see their customer reviews. So again, accounting is the communication mechanism for business. but it's not entirely quantitative. There are qualitative aspects to this, okay? When I talk about that, I did include a word bounce, scorecards, things like that. Accounting does embrace and acknowledge these qualitative measures to its financial communication mechanism as well. Okay, the information hierarchy. We covered this back in week one. You know, at the base, of course, the pyramid is data, followed by information, followed by knowledge, and of course, wisdom. And that is our goal, is to drive the data up the information hierarchy. We want to provide as much context as possible. With greater context, we'll have greater understanding, greater application. So again, this all goes hand in hand. And again, I use that example from the social security number. I put that up on the board. Do these numbers mean anything? Well, what if I put them in a table and give them a heading, SSN? And we know what that social security number is. We know that SSN stands for, it's the acronym for social security number. But again, we have additional knowledge about that. It's unique. There's a one-to-one relationship between the social security number and an individual. So if we can encode, record all of these things, and I just said something, encode. So now I'm going again back to week one. What is computing? Or what's a necessary first step? We need to symbolically represent the real world in our computer framework. So up to this point, we've been doing many things. We know how to encode data and text and audio and video. Now we're actually going to start to encode processes. When we look at information systems analysis and design, what are we really striving for is to mimic, represent, symbolically represent the processes of a business within the computer framework. Now, I added this too. Information. What do we strive for with our information? Memorize this, please, okay? Information must be complete, accurate, timely, and relevant. If any of these components are imprecise, then we're guessing, and we don't like to do that. If we have complete, accurate information that's relevant to what we're trying to do in a timely fashion, we can make very good decisions. It's when the information is incomplete that we have to do some guesswork. We have to use our intuition, and hopefully that's good. Of course, it must be accurate. If it's not, we have a saying within this discipline: garbage in equals garbage out. Okay. Timely. Okay. Of course, I need the information when I need it. Making a decision to get out of the stock market, it'd be great if I could, have it in advance, but I can't. Okay. Knowing that the stock market crashed back in the early 2000s, well, it didn't help me get out of it in the early 2000s, right? It must arrive in a timely fashion. And of course, it must be relevant to be applied. I presented this back in networking, but now we're really starting to look at it in greater detail. The difference, or the contrast between architecture and infrastructure. Architecture is a blueprint. And again, easy to remember this. What do architects, building architects do? They create a blueprint. But we extend this definition, okay? Not only defines the system's goals, but dictates when the components are maintained in place. And that's the challenge, because we don't know what's coming, okay? We don't have complete, accurate information about what's coming down the pike a year from now, okay? Nobody saw this pandemic coming. People forecast it, but did they really know it was coming and when? No. So it's very hard to prepare. And again, how do you pitch this to your CEO? Sir, ma'am, I think a pandemic is coming. We should leverage and we should start to move. Well, how much is that going to cost? A lot. Okay, no, we're not going to take that chance. Okay, again, information must be complete, accurate, timely, and relevant. We know that that's not possible, but we do our best. How do we do our best? Research. Okay, so architecture is that strategy or a blueprint. And I just have an example strategy. Okay. An organization purchases identical notebooks for all employees. Why? Because management becomes easy. If I have a homogeneous environment, it makes it very easy to manage. Of course, all my employees say notebooks. Um, I can extend this into the decision of, am I buying my salespeople iPhones or Android? Okay. I can pick up Android phones for a lot less money. But with iPhones, you have the standard architecture, which is nice. You also have the iTunes store. iPhones can be and are thought to be more secure because everything is coming through that Apple store. And Apple does their diligence. They really do assess the apps for the phones. The Android marketplace, it's the wild, wild west. There's a lot of malware, a lot of Trojan horses, because again, it's more of an open marketplace. So if I'm an IT administrator, I can give my employees iPhones. It's going to cost me more upfront, but maybe cost me less down the road because again, my salespeople, when they return to the office, are coming inside my firewalls, right? So who knows what they could unleash on my systems. So again, first thing I'm always thinking about, security, okay? And I presented this in the past. It's really difficult to get a return on investment for security. You don't know, you know, until you've been breached. If you've never been breached, well, maybe I could have done with something less, save some money. But when you're breached, it's quite often, I should have done more. Okay, so architecture is that strategy. Infrastructure, everything that supports the processing of information. And this is where, again, the non-computer people within the organization, they don't understand. And I'll give the example, you can purchase a $100,000 server pretty easily. That's not the cost. The cost is paying a system administrator 6 figures every year to support that server. And probably it's not just one administrator. Okay. So you can purchase servers, and I put that $100,000 number out there, but really 20, even $30,000. But I may be paying salaries of $200,000 just to keep that server running. So that's the true cost of architecture. Okay, so how do we get from architecture to infrastructure? Well, we're going to go through the system development lifecycle. But again, we need to speak it or phrase it in the terms of business. So it's going to be from an accounting basis. And how do we do that? Cost benefit analysis. We try to do the best we can on return on investment, the best we can on total cost of ownership. Okay. Planning for future requirements, to some extent, it's intuition too. We're throwing darts. And this is where I've said, we can never rest on our laurels. This is actually in the Association of Computing Machinery's Code of Ethics and Professional Conduct. It's our professional obligation to remain abreast of what's going on out there in the world. It's, continual diligence. We go to bed, we wake up in the morning, the world has changed. Should we, slack off, our competitors are not slacking off. So should something come around the corner, they're going to be better prepared to respond. So we're talking about systems analysis and design, but there are a lot of personal obligations to this as well. When we look at systems analysis, what are we doing? We are, of course, trying to achieve a business goal through the use of computing resources, so hardware and software. But later on, we're going to see in a minute, when we look at business resources, people, machines, money, information, we're going to see that we have many interfaces. And I've presented this in the past. So we have user interfaces. If the user interface is not good, people will not use the system. The system will fail. We have software interfaces. Going back to, you actually implemented software interfaces when you implemented pipes and redirections. If you're in programming in Logic 1 or Python, You are using system libraries. So you have those software interfaces. So you're already learning how to adhere to application programmer interfaces, APIs. And it's the API quite often that is the critical part of software engineering and information systems analysis and design. Because if you have an API, the linkages, how these things link up, when we talk about a digital signature between programs, okay, it uses, three variables to communicate between these systems. If you define the application programmer's interface well, then what goes on, you can't see my hands outside of the picture here, what goes on in the background to create those linkages, well, you can change that, but you want that standard interface to remain the same. So, and again, here it's planning for future requirements. You're planning an API, hopefully with the future in mind. And then, of course, we do have hardware interfaces. Integration. When I talk about systems analysis and design integration, there are actually three levels. Okay. The data. One way to achieve the data integration is use a singular common database. Now, many organizations don't have this luxury. They'll have some data in a Microsoft Access, some in an Oracle, some in an IBM DB2. And whenever you have multiple databases, if they need to communicate, you need middleware. And this middleware is continual overhead. If you think about it, one system, show my hands here, Microsoft Access, and I'm using it as kind of as a front end for an Oracle database. And you upgrade your Oracle database. Well, now you need to upgrade the middleware programming. Now the Microsoft Access gets upgraded, okay? So you see you have this continual flexing within the systems that requires continual management. If you had just a single database used across the enterprise, you don't need those middleware programmers, money, overhead. But also think about the agility that this provides. Okay, so you have a single database. It's used for, say, all the user manuals. And also it's used to record customer service, tech support calls. So someone calls in, they're having a problem with their product. And the tech support person helps them out and then sends that message to the technical writers. The technical writers they review their literature and said, oh, we could say that better, that in that user manual. And they rewrite it and they save it back in that database. And that database is also used for the web. So the very next person that comes to the website to download that user manual downloads that newly revised user manual the tech writer just finished, essentially making it better, perfecting it. That's incredible agility. Because now, if those users don't need to call tech support, right, you're saving money. Recall, tech support, again, is pure overhead. You've sold the product, information system, computer, whatever it is, right? You're not selling another, you're supporting something that's already out there. So anytime I can mitigate the costs of my tech support, I'm going to make more money. Goes right back into accounting. Accounting is that communication mechanism for businesses. Okay, so we have data. If I can use a single database, it's going to make everything easier. And actually, this is really when we're going to talk enterprise architectures. If I can have a singular enterprise architecture, a single architecture that serves all components of my business, I'm going to be far more efficient. Infrastructure. You can think about infrastructure as being solved. Infrastructure is how the information moves around. TCP/IP, right? Web interfaces, it's there, okay? The standards that we've used that are the internet and web today are the very things that are necessary for creating a seamless infrastructure level. Business process. and I laugh there. Business process is the most difficult. Why? It's people. I'm going to talk a lot about the relationships. because within business, people have relationships, and relationships are what allows a lot of work to get done. A system can be poorly designed, right? Maybe you're getting orders, but they're not shipping out. You call into the help desk or customer service, and that representative has a kind of a relationship with someone in shipping, and they're able to call down, hey, Jerry, Mary, whoever, please get this order out. This person is waiting for it. The information system failed. The people made it work. Now we can go the other direction as well. Okay, you've heard me say this over and over. Business organization, IT is a triangle. I won't go back into it. Um, I'm just going to ask you to read through this. There are things that are taking place, rapid change in technology, it's here. Rapid change in the environment, we've seen that in the past year. Um, Information systems must support business goals. Okay, we can't just implement something because, hey, that's really cool technology. However much we'd like to do that, okay? So information systems must support business goals, must support organizational systems. So when we look at what they're supporting, the people, the processes, and again, that's what we're encoding, okay? Symbolically representing. I'll introduce a term here, process mapping. Much of what a information system professional does is process map. If they're an external consultant, they're going to come in and look at the system and go, okay, we can do this. Now, another caveat. Information systems, our workers know that they're often used to downsize. We will face resistance. And this can be very problematic, okay? Problematic even for our careers because people don't want to be let go. People don't want their friends to lose their jobs. So within these structures, these organizational structures, they're thinking, why am I going to help this person create a system that's going to get rid of me? This whole process is rife with dangers. And you think about this, to really process map a system, you need to go in and spend a lot of time observing. And of course, you're getting paid for it, you're on the clock. And quite often, the senior level of that organization, they don't understand this. They're not information systems professionals. They want you to come in, just give us a new system, right? I don't want to pay you to sit there and watch what my administrative assistants do, even though they're the ones that are going to be using the system. And if those assistants, those administrative assistants within the organization are not engaged, they're not going to help you. And then when the new system comes online and they don't want to use it, what happens to productivity? It goes right down. And I ask this normally in the classroom. It's very easy to see. I'll put the question out to the class. How many of you have had new information systems thrust on you? You're out there working in a store. You come in the next day, there's a new point of sale system. How happy are you? Okay. Probably not. Okay. What happens to productivity? Now, of course, the senior levels within the organization, they observe the decline in productivity. And of course, this is your reputation for creating this information system. So now you're going for another contract, okay? And that new company calls that other company that you just did the information systems development for. They say, hey, how's that system working out for you? And that CEO who knows nothing about computer science, who didn't allow you to observe and properly implement a system goes, it's horrible. Our productivity is down, things like this. There goes your reputation. At some point in this, negotiation phase, you may have to decide to walk away, not take the contract. Okay. If I'm going to implement this information system, I want to observe these groups. I want to spend 2 weeks here. I want to ask them questions. I want to do all of these things. And if they say no, I can't do my job. There's no way I can give you a good information system. And I don't want that tied to my reputation. It's a treacherous, it's a very narrow path that we have to walk in this discipline. People and technology work together, okay? Yes. And quite often when we look at this, we focus on user interfaces. And I'll throw out, because it's not in the textbook, UX design, okay? Which is actually short for user experience. And there are many adages out there, you know, if a person can't find the functionality within the software, it doesn't exist. Who cares if it actually does exist? If they can't find it, it may as well not exist. We look at this in web design. And unfortunately, the textbook took out the chapter on web design. So I hope to supplement it as uh, best as possible. People should be able to wayfind. They should be able to navigate. It should be self-evident. And that's what we strive for in information system user experience or user interface design. So I spoke about this, okay? People do not like change, especially new information systems, which they know can replace them, okay? So you're gonna encounter all kinds of things. They will deny the system is up and running. They may sabotage the system. We won't get into that. Um, the best approach is an incremental, continuous incremental changes, because radical business reengineering is just that, radical, and people resist it even more strongly. Getting into some other aspects of information systems analysis design. And again, what I'm presenting here is not in the textbook, and it's critically important. One of the things you have to observe when you're working in this is the organizational culture. And this came out of Harvard Business School, is there are two perspectives, the business functional view and the business process view. The functional view is that, traditional silo. I have accounting, I have web, I have HR, okay, I have all these silos. And information tends to go up, and only cross at the top boundaries. The vice president of HR, the vice president of accounting, the vice president of whatever, okay? It doesn't really support innovation, because many people throughout the organization, because they know what's going on, will actually see what needs to occur. The better, okay, more effective organizational culture is the business process view. When we look at, say, inbound logistics, outbound logistics, how are orders taking place? Actually, the way the customer sees the business, the entity, the organization. Now, there's much more, but I think I'll stop right here on this page. We just need to recognize the 4 business resources: people, money, machines, and information. And that's in no particular order, okay? And it's changing, machine learning, people are the most important, without a doubt. You can't run a system without a system administrator, okay? Very specific, precise knowledge, Linux Lab 9 and beyond. Money, well, if you have money, you can buy people, you can buy information, things like that, okay? I should have said pay for people, pay salaries. Machines, and of course, information. And again, here's that, it's changed. The focus that was previously on technology and all these things is now moving towards who has the most data. So again, I'll stop here, and now we'll jump into the textbook material. Okay, so this is what, of course, you're responsible for the quiz. But again, read through what I just presented. By the way, I'm going to leave you with one other thing here from back on CISS100.com. I actually gave everyone a cheat sheet. Down the road, 5 years from now, 10 years from now, who knows? When it comes time to do any systems analysis, if you go out there and consult to create websites, things like that, and everyone will be prepared. If you do the LAMP installation in the final project, you will be prepared to go out there and be a web administrator, web designer after this course. So to this effect, bring this with you, print it out, and answer each one of these questions. Answer each one of these questions prior to beginning your design and development. It's going to give you an understanding of the organization and what they intend to do. Okay, so these are the questions here. And then in a little more detail, okay, once all of these questions are answered, what are the key business processes, what control systems, the culture, things like that, then we break it down into further detail. Okay, so implementing it. Okay, who does what? So again, just note that this is here, lecture module 10, CISS100.com. Took me a while to compile this. This is actually the basics from a grad, and say if you were to do a master's, Master of Science in Information Systems. These are the key questions to ask, and that must be answered. Okay, so here we go, textbook information. What is an information system? Collection of elements and procedures, okay? Hardware and software, okay, that interact to accomplish a goal, okay. What is an information system? Generates the information needed to support the users in an organization. Memory hierarchy. We push it up from data to information. We push it up from information as high as we can go, knowledge. Getting up into wisdom, AI, okay, heuristics. We'll talk about that more at some point. So, enterprise architectures. Enterprise architectures are the goal. Okay, when we talk about an enterprise architecture, the ideal enterprise architecture, it is consistent, has that singular database core. Okay, and once you have that, that's actually quite a bit of it. Because again, the integration, how do I get the information from the database out and about? Again, we have those internet technologies, TCP, IP. And then of course the business processes, we just look at all the components within an organization. What information do you need and how do you need it, in what format? Okay, so when we look at enterprise systems, again, they must support many different levels throughout. Again, I don't want a separate system for my middle managers, a separate system for my senior staff, so to speak, on the strategic decision making. Okay, I want a single system, because again, over time, it gives you the flexibility to adapt to changes out in the environment. And there are a lot of business forces. We're going to look at that as well. So I'm going to come back to this triangle, okay? And you'll see, of course, we have a lot of employees, fewer operational managers, even fewer middle managers, right? Directing the operational managers. And then of course, your senior decision makers. And we're going to come back and take a look at this, because this pyramid also is going to reflect the nature of the information. What do I mean from that? Okay. What must information be? Complete, accurate, timely, and relevant. At the lowest level, you may be able to achieve complete information. It must be accurate. Well, to state that, timely and relevant. Okay. I give the example of, in the former pre-pandemic, Black Friday staffing. I know from the past, these were my sales for the last 10 or 20 Black Fridays. So for an operational manager, this is how many salespeople I need on the floor. It's essentially almost complete information. It's accurate because I've maintained it. It's timely because I have it from the past, so I can apply it in this coming model, right? And then of course, relevant, it's entirely relevant to what I'm doing. Middle managers, okay? Tactical decisions. How many winter coats do we carry? Things like that, okay? Well, what's the winter gonna be like? That's imprecise. There's some unpredictability in there, okay? So middle managers typically are dealing with less precise. It's not complete information, right? Executive managers, should we even have a brick and mortar store, And now with the pandemic and the lockdown, it's really a relevant question. Okay, so here is the system development life cycle. Typically, you're only going to see 5 phases. This is actually the first textbook I've ever seen with a 6th phase, acquisition. Because really, acquisition in other textbooks will be in the implementation phase. Okay. So I don't know if any of you are in, sci-fi, and this is really dated, and I'm sorry about this. Star Wars, Padme, planning, analysis, design, implementation, maintenance. Padme. Okay. We have to subject ourselves to this system development life cycle. And we're going to see it's very similar to the program development life cycle. And I know those of you who are in programming, Professor Hurd always coined it as combat programming. When people learn how to program, they just dive right in. They don't restrict themselves or subject themselves to the planning, analysis, design, implementation, maintenance, but that's what we have to force ourselves to do. Just like in day one, when I said, nobody has ever taught you how to read computer science. And it's misleading because you're going to see terms that you think you know, but they have a very precise meaning in computer science. And that's critical for your foundation, for your subsequent learning. Software design, system design is very different than traditional design. We're going to see that in just a minute. So when we look at systems development, it can be internal, it can be outsourced. If it's possible to do it internal, well, of course, your internal people know the organizational culture. They have relationships throughout the organization. They may have been hearing for years that this item has been a problem that negatively affected their customer service. You go to outsourcing it, and that's a whole new ballgame. Some people within the organization may be shy. Just personally, they're shy, so they're not going to speak well or reveal everything to these outside contractors. There are various levels of outsourcing: offshoring, nearshoring, home sourcing. I won't get into that. But let's look at the approaches and why system development is so different from other disciplines. In systems development, we follow an iterative approach. Okay? At all costs, avoid a waterfall model. Okay, why? Let's take a look. The waterfall model, as my mouse is kind of brushing over here, is traditional engineering. We look at building a house. Okay, what do you do? Okay, I want to build a house. Planning. I know, I hope to have children, so I want a good school system. I want a good neighborhood, good environment, right? So I'm kind of moving into analysis. Then I'll contract, say, with an architect for the blueprint. And once that blueprint is developed, quite often it's essentially just passed off to the contractors, to the builders, to build the house. That architect may have minimal involvement moving forward. So you can see it's a stepwise approach. You really don't go back. Once you purchase the property, right, you've done your planning and analysis, and you have the blueprints. It's not like the normal person can go back and go like, oh, I don't like where the property is. I'm going to buy a different property. That gets expensive. And that illuminates something else. If we catch errors early, there's far less cost. So I'm having a house built, and I specified 3 bedrooms, 2 baths, right? And construction has begun. Now, suddenly, I want 3 bathrooms. But the house is on a pad, poured concrete, right? Where the pipes are actually in the concrete, radiant floor heating. To change and add a bathroom, I have to go back to the architect. And then, of course, I'm pouring new cement. I'm trying to integrate with other systems. Maybe I had already designed, this is the necessary pump to move it, but now I need a larger pump, a more powerful pump to move the water through. Okay, you can see where the costs are going up. If I can catch things early, and this applies to technology too, I'm manufacturing chips, right? If I can get better materials, I'm going to have fewer chip defects. So what I'm really talking about now is managing the supply chain, which of course the internet and World Wide Web has also facilitated. I can do that much better. But software design uses an iterative approach because we recognize we're in this volatile environment and things will change. So we do some investigation, we do some analysis. That analysis may lead us back into further investigation. I may have identified something that I was completely unaware of, right? I need to go investigate it again. I do some design. Maybe I come up with a problem or something new arises out in the environment. 2008, the iPad is launched. I'm in the middle of the design. It's like, uh-oh, this new device. I better go back and do some analysis. So in software design, we have this iterative, okay, method. We continually iterate over past phases. We're going to introduce rapid application development, okay, just in time, delivery systems. All of these things require this iterative analysis, recurrent, repetitive, however you want to say it. It's not a waterfall. Once I'm done with my analysis, I'm done. That does not occur in systems design, which makes systems design just incredibly complex. Okay, I am out of time here. So that's all I have for today, and we will finish up the chapter. We'll pick up right here tomorrow, and that's it. See you all tomorrow.
Thank you, Professor.
Of course.
Thanks